Hello everyone, in this video let's discuss about 1:4 DEMUX. So we can also call it as demultiplexer. DEMUX means demultiplexer. So to get more marks in demultiplexer problem, so we should write 4 steps. That is, first one will be of drawing the block diagram. Second will be of drawing the truth table. Next, third step will be using this truth table we will be drawing their equations, that is logic equations. Fourth will be using the logic equation we will be drawing their circuit diagram or logic diagram. If you follow these 4 steps, you will get full marks in DEMUX. So first, how to represent the block diagram. In block diagram, we need to keep in mind that only the inputs and the output must be represented. So if I call this a block, using this we should prepare a diagram. See, 1:4 DEMUX. What it tells? 1 input will be there and 4 outputs will be there. So let me call the input as I. So you can use any of the alphabets also. Now let me call the 4 outputs. So I will call my outputs as Y0, Y1, Y2 and Y3. So therefore 0 to 3 means 4 number of outputs. So to get the outputs, the input will be coming through these outputs, one of these output. So which output will be selected among these 4 will be decided based on the selective lines. So how many selective lines are required for 1:4 DEMUX? So just see, what is the output? 4. So how can we represent 4 using 2 powers? That is 2 power 2 is 4. If it was a 1:8 DEMUX means how can we represent 8? 2 power 3 will be 8. That like, what is the power value here? 2. So we will be using 2 selective lines here. Here for 1:8, that is 3 is the power, we will be using 3 number of selective lines. Let's name the selective lines as S0 and S1. With these selective lines we will be having additional input, that is enable. When the enable value will be equal to 0, no operations will be processed. That is, no output we will be getting. If the value is equal to 1, then only we will be getting the output. So keep in mind, while drawing the truth table, whenever the enable value will be equal to 0, just stop the process. That is, output will be 0. Now let's draw the truth table using this block diagram. So you can write 1:4 like this. Now truth table we will be representing the inputs and the outputs. So in the output side, what we are having? In output side we are having Y0, Y1, Y2 and Y3. We are having 4 outputs. Now at the input side we cannot use I, we will be using the selective lines and enable, because these selective lines and enable will be responsible for producing this input as output through one of these output gates. So what are my inputs? Enable, S1, S0. So these will be my inputs. So I said whenever the value of enable will be equal to 1, then only my output will be given. So I will take enable value as 1 for all the operations. So 1, 1, 1, 1. I took 4 times because if I eliminate this enable, we will be left with only 2 of the inputs. What are they? Selective lines 0 and selective lines 1. So therefore, if we consider these 2 as the input, what will be their combinations? 0, 0, 0, 1, 1, 0 and 1, 1. Now let's fill the output side of the truth table. So let us consider, if enable is equal to 1, S1 value is 0, S0 value is 0, then the input I will come through Y0. So I will write I for Y0, all other will be 0. Next, if enable is 1, S1 value is 0 and S0 value is 1, I will consider the input I will come through the output Y1. Therefore, other will be 0. Now, same. Now I will consider for Y3, Y2. Next, I will consider for Y3. So now we completed the truth table. As I said earlier, using this truth table, we will be designing the equation. So how to design the equation? We must be designing the equation for all the outputs. So what are my outputs? So my output, let us consider it as Y0. For Y0, first one is Y0. For that one, we should write all the inputs also, including this I. So what is that? E, S1, S0, I. But S1 value and S0 value is equal to 0. So I will use S1 bar and S0 bar. If 0, S1 bar, S0 bar. If it is not 0, S1, S0. Like that you can write. Now for Y1, second output Y1, what will be the equation? E, S1, S0, I. What is the value of S1? S1 value is 0. So I will use bar, and S0 value is 1. So I will leave as it is. Next, Y2. Y2 is equal to, so what is the value? E, S1, S0, I. What is the value of S1? 1. So I will leave as it is. What is the value of S0? Its value is 0. So I will use bar. Next, Y3. So Y3 will be E, S1, S0, I. See, E, S1, S0, I. So now we completed the equations. So using these equations, we will be drawing their circuit or logic diagram. So to draw the circuit or logic diagram, what are my inputs? Common inputs. I is common in all, enable is common in all, and S1, S0. So first I will consider I. Next I will consider enable E. So enable E I will give like this. Input I will give like this. Next, what are my another two inputs? S1 and S0. S1 and S0. S1 have S1 and S1 bar. So I will use NOT gate. Next, S0 also have S0 bar. I will use NOT gate. So using this, we will be constructing the circuit diagram. Y0 is equal to enable S1 bar. S1 bar means from 0 you must take S0 bar, S0 bar and I. So we will be using the AND gate because in between them dot is there. Nothing is there means it's dot. Next, Y1. So this is of Y0. Y1 means enable S1 bar, S0 and I. So we will use AND gate Y1. Now for Y2, enable I is common, no, enable I, S1, S0 bar. S1, S0 bar, you will be adding AND gate, output is Y2. Next, only one is left, Y3. Enable I, S1 and S0. We will be adding AND gate, so Y3. So now we completed the circuit diagram also. If they ask in exam, first write block diagram, next write the truth table, next using the selective lines how much we need, write the equations after you must write the circuit diagram. If you write these 4 steps, you will get full on full marks. Hope you understood the concept of 1:4 DEMUX. If you like the video, please subscribe and support. Thank you.